smart computers are invading our lives, businesses, and processes. Because right now, Siri's not much help to me, but she's getting better and soon will be helping me shop or handle business transactions, and I'm going to expect businesses to be able to work with her. I'm Dan Neason from Whitestein. You may know us from such conferences as this one, last year's or 2013, but we do more than just headline the bpmNEXT events. We're a firm with years of success in delivering innovative solutions. So why do we always show up and talk about intelligence? And it's because Whitestein came into BPM from a world of intelligent agents, optimizing areas like manufacturing, logistics, and telecommunications. So we're not BPM guys trying to figure out IA, we're IA guys who recognize BPM as a path for business alignment. So smarter machines, devices, and massive amounts of data are going to create challenges for organizations. They'll require intelligent solutions, but what does that mean? Let's look at some of the characteristics of building intelligent systems. To be intelligent, you must have some understanding of who you are and what you're capable of doing. This provides a basis for higher level thought. From our earliest days, babies quickly understand that they're a person. Reflection in machine intelligence doesn't mean the same thing as it does in humans. As we all know from Star Trek, machines have no emotion, so their self-awareness doesn't come with our baggage. What is required is that the whole of the system understands what each part is and how it can be used. For example, in LSPS, we've added reflection capabilities at every layer of the system, and now the engine can ask running models what they're capable of doing. The LSPS will then use this introspection to determine what actions, either predefined or ad hoc, can be driven in the process based upon the capabilities of the model. To be intelligent, you also have to have the ability to plan and navigate. The ability to understand a goal, survey the environment, and then choose or create a plan to achieve your goal. To operate in complex problem spaces, a system must understand what is to be achieved, how it is allowed to achieve that goal. This requires establishing clear outcomes or clear goals and the constraints that system must work within. It's no accident that the LSPS aligns directly to this concept. The tactical goals select what plans need to be executed, and the strategic layer moves you up into a network of goal agents that identify non-obvious relationships and options. Predictive analytics, complex event processing, and adaptive case management are all simplified and enabled through this structure. And the combination of planning and reflection in LSPS, we've established the infrastructure to move to even higher levels of intelligence. To be intelligent, you have to be able to learn from your experiences, change your behavior, and improve. The ability to relate new input to previous events and experience in order to come up with better plans. In machine learning, the goal uses reflection to understand its environments and previous events to predict ways to optimally achieve the goals that have been laid out. The foundation of reflection in LSPS allows us to create models that evaluate and determine the best plan. This model contains a Markov decision process and suggesting an ad hoc process in order to achieve the goal. Thus, we use the LSPS to build an intelligent system on the LSPS. In previous events, we've shown the goal structure enabling ACM and the inclusion of external agents. This year, we're going to demonstrate the ability of LSPS to evaluate events, detect patterns, suggest actions, and predict outcomes. So we're passionate about intelligence, and we believe that BPM should play a leading role in helping to transform operations to deal with these changes. This is really throwing off the idea of us as an industry just being about workflow, and really we are moving to become the providers of intelligent modern management platforms that organizations need to interoperate with massive amounts of information. And now I'll move over to the demonstration. So in order for us to, our goal was to demonstrate very clearly building an intelligent system using our software. So what we did was we came up with a scenario of a bank running a campaign on top of their CRM system, and the campaign is all around what we have here, and I I purposefully left the resolution a little off, so you'll see me moving the scrolling back and forth, but it actually, I think, shows a little bit better once we get into some of the more detailed screens. So here's my campaign, and here are all my target people, and I've got some color-coded statuses as they go through, and my job as a mortgage rep in the bank is to actually move somebody through the process. So if I come to my to-do list, I'll see that I've got a mortgage assigned to me. I've taken the time to pre-fill some of the information here, and I'll come in and click continue. The first thing I receive when I click is that I receive a notification from the system of the preliminary checks that it's done. So it sees that I've got an anti-fraud check is still undecided, but that I've succeeded through risks and credit checks. So I'll just close that and continue, and we'll put in some quick information here. And I just moved through the process, left it so that you wouldn't have to watch me go through each step in the process. So I come in, and as I move through here, when I click continue, so I'm just moving through the process, and when I hit this point, the system has actually detected a pattern. So the system stops me, and it's evaluated all the cases moving through the campaign, and it's looking for a particular pattern. And this pattern is for this pattern is detected for potential fraud. And so the system sees that. It predicts that these cases are all matching this pattern, and that they may fail that fraud step, and then it actually is choosing a recommended ad hoc action. So what we're demonstrating here is that the system is not only using the analytics around key performance indicators to identify this pattern, but also using introspection into the model to say, well, what are we actually capable of doing? Not as a predefined path, that this is actually an ad hoc path. This is the system going in and saying, what is the model capable of doing, and what is the best way for us to achieve this particular outcome, which is to keep this from happening. So I can come in and I can see that it's told me that I should come in and work with my colleagues in the bank to make a determination, to review these cases against each other. So I can come in and I can say, please review at the top. I can select Sally and say the case for Brad Fowler. Can you compare the cases side by side, and then actually come in and run that. So the system suggested my path, and I took it. Now I could also, at that point in time, I could tell the system that this is a bad suggestion. And the reason you would do that is to give reinforcement back into the system so that it actually can learn and say, well, every time I suggest this, it gets turned down. Well, I won't suggest that anymore. Another side of this intelligence is actually using the goals for really predictive analytics. So if I come into the main portal and open up my campaign, my detail, and you can see that off to the side, the campaign lays out statuses based on colors for each one of the steps. But I can come up and I've got a hidden panel here for campaign performance. And if I come in and say, let's look at the success rate, I can see that it's showing me what you would basically think is a regular dashboard for what's our success rate going to be. But if I move to forecast, it can actually show me what it anticipates that I'm going to have. And then I can actually come in and ask the system, okay, now based upon your forecast, what are cases that are almost guaranteed to fail? What are cases that will succeed? What are cases that are really hanging in the balance, right? What are cases that, these would really be the cases that you'd want to work on, because if you see this, then you can, if you see those cases, you'll see that they're ones that are sort of, at this point in time, hanging in the balance, right? The system's identified these as ones that can be saved. And so I can either open these things up directly, or I can come over here and you see we've got a little game controller, and I can determine my own ad hoc actions. Now these are ad hoc actions that have been defined in the system through the web UI and established. So these are things that have been predefined, that we've predefined. But in fact, it's something. These are different actions that I can take. So that's what I wanted to show. So what kind of questions do you guys have?